Welcome, students, to Episode 1, Basics of Fluids. Before we dive into pressure, buoyancy, and Bernoulli, we must understand what a fluid really is. Most students think fluid equals liquid, but that's not true. So let's start from the very foundations. A fluid is any substance that cannot resist shear stress. Meaning, if you apply even a tiny sideways force, it starts to deform continuously. That includes liquids and gases. So, all liquids and all gases are fluids. Solids resist shape change, fluids do not. That's why they can flow. One of the most important quantities in this chapter is density, represented by the Greek letter rho. Density is defined as mass divided by volume. The formula is rho equals m over v. The SI unit for density is kilograms per cubic meter, and the CGS unit is grams per cubic centimeter. Typical values include water at 1,000 kilograms per cubic meter, air at approximately 1.3 kilograms per cubic meter, and mercury at 13,600 kilograms per cubic meter. Remember, JEE loves comparing densities. Next, relative density, also known as specific gravity. It has no units, as it is just a ratio. The formula is the density of the substance divided by the density of water. If RD is 0.8, the object is lighter than water and floats. If RD is 2, it's heavier and sinks. This simple ratio helps us understand buoyancy. Now, let's talk about pressure in fluids. Pressure is force per area, but in fluids, it is scalar and acts in all directions. The formula is P equals F over A, where P is pressure, F is force, and A is area. The SI unit is Pascal, or newtons per square meter. Important: gas pressure and liquid pressure work the same. Pressure is always normal to the surface. We'll derive this fully in Episode 2. For now, the idea: deeper you go, more fluid; above you, more weight, more pressure. This formula, P equals rho GH, is the backbone of many questions. Simple idea, but asked often: gauge pressure versus absolute pressure. Absolute pressure is pressure including atmospheric pressure. Gauge pressure is the absolute pressure minus the atmospheric pressure. For example, a car tire reading 30 psi is gauge pressure. The actual pressure inside is 30 psi plus atmospheric pressure. Even though fluids are made of molecules, we treat them as if properties like density, pressure, and temperature are smoothly distributed. Why? Because on macroscopic scales, molecular randomness averages out. JEE Advanced may ask conceptual questions on this. Common mistakes students make: thinking density changes with depth, mixing up gauge and absolute pressure, confusing relative density with density. Also, forgetting pressure acts in all directions, and assuming fluid must always move. Static fluids exist. Quick revision: fluid equals anything that cannot resist shear and flows. Density equals mass over volume. Relative density is density relative to water. Pressure equals force over area. Pressure increases with depth. And remember the difference between gauge versus absolute pressure. This is your base. Episode 2 will build on this to derive P equals rho GH properly and understand Pascal's law. Now that you know the foundations, it's time to explore the real power of fluids, how pressure behaves in depth, and how we harness it in hydraulic machines. Join me in Episode 2, Pressure in Fluids plus Pascal's Law.